pointers is the derived data type that is used to store the address of another variable, and can also be used to access and manipulate the variable's data stored at that location. Pointers are considered as derived data types. All right, so that's basically all there is to pointers. It's this is a basic explanation of what pointers are. I'm going to do my own explanation. I'm going to like explain to you what it is in an easy manner to see if you guys would understand me better. So you ought to read all of this. You ought to read all of this. But then I'm going to make it easy. I'm going to explain in my own way. Why are pointers even important? You know, traditionally we used to manipulate variables, and we used to store values to variables with different types. So there are a few things that we all need to know when it comes to using or manipulating a variable, you know, using it how we want to use it. There are a few things that we cannot do that we need pointers actually to actualize, you know. And those are the things that I'm here to point out. First off, the first thing that's very important that you need to know is that a character, the computer reserves, see, each time you create a variable, what the computer does is it creates space somewhere in its memory for the variable to be stored. So when you initialize a variable, like saying int n, when you declare a variable, what the computer does is it checks the memory, and then it creates space that is to be allocated to that variable that you've created. In essence, it has to know the type of variable. That's why we always initialize variables with their type. We tell the computer what type of variable. The reason why the computer needs to know what type of variable we are creating is the computer needs to understand how many bytes to create each time you declare a variable, you know. So characters are 1 byte, and then uh, integers are 4 bytes. Integers are 4 bytes. Floats are as well 4 bytes. So each time you declare a character in programming, what the computer does in the memory is it creates 4 bytes of space that and associates that 4 bytes with that character. So anytime you change that character, the computer changes the character in that 4 bytes of space that has been allocated to the character. So this is how memory usage happens. This is how the memory that you spend, this is how it comes about. This is the grassroots of it. And if the variable is an integer, is going to create 4 bytes. On most for 64-bit operating systems, pointers, as we are to learn today, the computer creates 8 bytes for them. 8 bytes to store them. Well, this that I have said to you will be important for you to note when you start allocating memory and all that stuff. But for now, let's concentrate on what pointers are. So, like I said, pointers save the address. They save the address of a variable. That we save addresses of variables. I'm going to explain practically about this stuff. So we are going to use, okay, like I said, these theories that we are talking about, uh, you should read them, but then you should know that our class material, the assignments that are in your portals, are built to ensure that you clearly understand what pointers are and how to use them. So, like I have said, that the point to address is I'm going to go solve a few of your pointer assignments, and then at least the ones that make you understand the concept, I'm going to go solve them. And then from there, I'm sure that you understand exactly, because I think I'll be able to explain better to you while solving your assignments. Yeah. So that way I'm able to explain better to you. Yeah, good morning, Emmanuel. Nice to meet you on this training platform. I'm looking at you guys as I try to teach. Okay. I'm going to go right into it. Let's go straight to this print F. No, it's supposed to have pointers somewhere around here. Okay, go right into it. Yeah. So, like I said, go and finish reading all these materials. Watch the videos; they would help. I'm just going to go straight because I want this class to end in an hour. I'm going to go straight to your assignments to help you and explain as much as possible while tackling the assignment. So this project says you should know what pointers are and how to use them. All the materials are there, and I'm going to do a little bit of explanation, so you should learn that too. You should know what arrays are and how to use them. We'll try as much as possible to use arrays while solving these taxes. Okay, difference between pointers and arrays, you should find that out while learning this and doing these assignments. How to use strings and how to manipulate them. This is very important. This is why we learn pointers. This is what pointers help us to do many a times, how to manipulate things, you know, variables, you know, is very important. I'm going to show you a lot of things here. And here, what does it say? Okay, this is how to compile and all that. So all of this stuff is not necessary right now. Let's go straight. So they say write the function that takes a pointer. Write the function that takes a pointer to an int. Write the function that takes a pointer to an int as a parameter and updates the value it points to, 98. Okay, so we should write the function. We should write the function. The function should point to an integer, and then it should update the value of the integer to 98 without actually updating the integer variable. We should update the pointer. The pointer should update the integer itself. So if you watch here, you would see in our sample main code, main file, that you see the main function is saying int n, and it's saying int n is equal to 402. Now we are print fing int n. At this point, when we print when we print n, the value of n, you can see n is equal to 402. Now our function that we are to write is going to be reset to 98, and reset to 98 is going to take the pointer. In essence, we are going to set this pointer to point to the address of n, and then we'll print the value of n again, and now the value of n should be 98. I'm going to tell you how unique this is. This is unique because we can actually change the value of n, int n. We are changing the value of n without actually changing n, the variable n itself. We are changing the value of n from changing the pointer to n, to the value of n. So it is the pointer to the value of n, which is the address of n, that we are going to work on. I'll tell you why this is very important in programming, in C especially, while trying to solve this problem. So let's go right into it. Let's go right into it. We have to print F this one. Okay. I haven't opened this stuff for like ages. Okay. Stuff is loading up. It's taking too much time. Okay. Um, what do we call it? Okay, let's see the test. And let's create a value, make directory to pointers. Let's make a pointers. Uh, let's go into it. So there's nothing here. We are to create all files and folders. So first thing we should do here is let's get our main.c file, the one the question is telling us to work with. So the question is telling us to work with this main.c file here. This is what we use in testing our code, our reset to 98 function if it works. So we are going to call it, what do they call it? 0-main.c. That's what we call it. So let's create that. So we are copying this, our main.c file, and let's come here and put it in. Okay, let's use cat 0-main.c, and let's paste this stuff here. So we have that done. I used Control D to get out of that place. So we have the main.c file that I provided for us. Let's check it. And remember what I said this place is doing. We created an integer n, and then uh, n is equal to 402. Here we are printing the value of n, and the value of n was 402 at this point. Now we are resetting to 98. We are resetting to 98, and change over. We are resetting to 98, and we are not doing that by changing the value of n directly. We are changing the value of the address of n. That's what we are doing. That's what this sign feels like. It's how you know we get the address of a variable, you know in C. Okay, so let's go check this out, and when I finish writing the code, I will explain to you why this is peculiar. you know it's very, very important to know this very helpful trick in C programming. um let's clear this stuff. And what did they say we should call it? I think 0.reset to 98. Or was it just reset to 98? Let me see. Trying to ensure that anyone I've solved, you can just copy it from my video. And okay, 0-reset to 98.c. Where's this stuff? Okay, so this one we want to actually make a file for it. 0-reset underscore to 98.c. Yeah, so that's what it is. I think we should include a main.h file where we'll define our yeah, to make sure that everything is. Last time I taught you guys about main.h, and in our main.h files we were defining all prototypes that we would use, and then we were calling the main.h file at the top. So basically what I should do here is to call a main.h file. What's going on here? So let's create a main.h file first. Main.h, and then we want to create okay, so void. What was the prototype of that stuff? This stuff is it was okay. I can they didn't give me a prototype here, so I'll create my own prototype that I want. Remember, I can okay, there's a prototype. There is, the question actually specified. Okay, so we are using void. This, remember, this is the parameter it takes in, this is the return value. We don't want it to return anything. All we want it to do is to take in an int and convert it, change the value at its address, at the address of n. That's all we want to do. We want it to change the value stored, the computer is storing in the memory at the address of n. So all we have to do here is carry out that operation, and we don't really need to return anything. So that's why it's void. So we can even copy this stuff to make our lives easier in the main.h file and just paste it here, right? So that's what there is to creating like a prototype for the function. We'll save this, and then we go create the zero dash the vi zero dash reset to 98.c. Yeah, so that's it. We just created our prototype. So right here in reset.98.c, one thing we can do is we can simply include our main.h file. So include it. Let me change this to standard US keyboard. What's going on? Yeah. So we are including the main.h. Remember, the main.h is not like the way we include a standard library. That one has curly braces or greater than and less than sign around it. So remember to leave a comment. I'm not going to leave a comment here, but you should do that. So the next thing is our function that we are building here, and it's supposed to be reset underscore to 98, and it takes in an integer and it points to the address of n. It points to the address of n. Yeah. So we are not returning anything else. I would have started by putting the return statement. And all we have to do here is we are going to set the address of n. We'll give it a value of 98. That's all we have to do. This is pretty much all that we have to do. What this is doing is checking the address where the computer stores n. It's not the value of n is trying to change. I'm going to use different variables for the next question just to make you understand. I feel like because the question requires us to use int n here, you don't know what it means to create a pointer. You feel it must not always be n here, okay? And let's just do that. Let's do that first. Let's save this and let's see if we are correct in uh, dealing. So we have a main.c file. We have all that we need. So first thing I want to do is chmod u plus x. I want to give execution permission to all these files, ls. So they are all green. It means they all have execution permission. Let's go back to your question. And what's your question saying? The question is saying GCC we should run for main.c this and this, and we should put them into a file called 0-98. So let's just copy this, make our lives easier. And let's run it. Hopefully we don't have an error here. I think we do. What is he complaining about? He's saying reset to 98 expected equal to. So like I said in debugging class, the first step to debugging is not getting frustrated. So we should look at this stuff critically. So reset to 98, error expected something that's not there. Okay, I guess the problem here is Azam attribute string. Okay, I guess we forgot something in our reset to 98 file, and I think it's the hash that it's complaining about. Um, vi, what was the name of this? I think we did this in zero dash reset, right? Yeah, so we have to have a hash sign here in this include. I've been writing so many other languages. I actually, some languages don't require us to write that way. I thought we just uh, use the function here. Okay, let's copy that again. Copy and go back. See if it's still going to complain. Okay, so it's not complaining anymore. ls. Yeah, so we have our 0-98. That was the error. So I told you, each time you have an error, calm down and read. Everybody makes errors. So I just forgot that before they include, we should. And this is just because the languages I've been writing all week, before include statements, we don't have to put an hash. So, you know, sometimes, like I told you, if you learn programming the right way, you'll be writing so many languages, you would not be stuck with one language. And that's what here in Nigeria they do to a lot of persons that are learning software engineering. They come and they just teach you one language. They don't teach you how to program. So you aside from that language that that you were being taught, you are not able to write any other language. Okay. So first things first, let me print out the results, and then I would open a browser to find any picture, any pictorial representation of how pointers work, or how stuffs are saved in the memory to show you guys. So what we are doing here is, let's print this out. 0-98. Okay, you can see it. At the first time the print statement ran, n was 402, and the second time n is now 98. And what we are changing here in n, cat 0 dash, I think is main I should be opening. Yes. So what we are changing here in this function, this function did was, this function assessed the address of n of the, remember, before now we've been writing code, and we've been using variables, but we don't used to use this and sign here, before the variable. This time around, we decided that we need the hand sign, and this is because we want to access the address of memory where n is being stored. That way we can change it. You can actually use another variable in the next one I want to try. I'm going to use another different variable to ensure that you understand what this feels like, because I feel like this will be confusing, because the name of the variable is n, and the name of the pointer is still n. See, the pointer can be stored in another. Let me see if I can browse something out for you, something that shows this stuff. Let's say diagram explaining how computers store So let's see. There are a few diagrams that could pop up, images. I know what I'm looking for. So pointer address variable. Okay, a pointer here. I think I've seen one that explains a little bit what I want. Okay. I've seen one explains what I want, but I want something that would make you really understand. Okay, let's see this. This looks good. This looks good. No, no, it looks too complicated for what I want. I feel like using this diagram. So easy. this one here. Okay, so this is how the computer memory looks. It looks like this, something like this here, where you have this one, two, these are all spaces, you know. Now, this is a pointer pointing to the address of 4, you know. This pointer is pointing to the address of 4. Now, the 4 could be holding, this point 4 could be holding a variable. Let's say the variable y. And this variable y that is stored here in this point 4 could actually be uh, holding a character. Let's say, what is your name? Is holding like a string. What is your name? You know, what pointers are pointing. They are it's another address. A pointer is another location in the memory. Same way 4 is a location in memory, pointer is another location in memory. It's still supposed to be on this same line here. Like this 4, this pointer 4 could be in address 1, and then the variable could be in address 4. Address 1 here is going to be pointing, like just the way this arrow points to 4. It's going to be pointing to 4. And each time we change the value in address 1, you can actually use that. Changing the value in address 1 can actually change the value in address 4, because address 1 is pointing to address 4. So that's how pointers work, you know. If we are to remove pointers from an integer and we are to say that, okay, I'm going to do that practically. Let's I think I've explained what pointers feel like. This address in memory is pointing to this address in memory, and changing this address automatically changes this address. So sometimes you don't want to change this value directly. You want to change something else that changes this one. That's where pointers help you. You know, you can create a pointer y that points to another variable a, and then changing y actually changes a. You know, that's how that's just a rough understanding of what pointers feel like. That's what we just did here. We changed the address of n, and it actually changed the value of n. So that's that for that. Let's look at our second question, and let me, you know, so um this one says we should swap, you know, write a function that swaps the value of two integers. This one says we should swap the value of two integers. Yes, I'll use this one to explain, and then I can leave you to do the rest, or I can do maybe one or two more for you. And just because of our time, I don't want our classes to be too long, and I want you guys to have the opportunity to stress your minds and understand this stuff. You know, I'm not here to solve all your assignments for you. No, I shouldn't be doing that. I'm here to make sure that I solve enough questions to make you understand the concept, and then you go stress your mind to solve the rest. That's how you become an engineer. Because when you get a job, when you land a job in the future, I'm not the one that is going to think about your workflow algorithm, and I'm not the one that will think about it for you. You will think about it. Your brain has to grow, your mind has to grow to the extent where you see these technical things and you're able to understand it. So think about it. The only way you can achieve that is by giving it time. The only way I could achieve setting all these questions for you, if you see here, you see that I've already done this stuff before. I have printed this stuff. I've tested it before. See it. That's my name here. You know, that's to tell you that every single question here has been tested. So nobody can come online to tell me, hey, this question was not correct or something, or I couldn't solve it because it's not solvable. I've solved it before. That's my username, you know, on my own Ubuntu. Anyways, um, write a function that swaps the value of two integers. That's what we are doing, and we are going to our main file to throw in this. I'm just going to copy this because we don't want to waste too much time on this stuff. So we'll go to our we'll go and define this ls. Where are we going to? Main.h, yeah. So vi main dot h, yeah. So let's throw this in here. And let's save. These are, you should take in two integers and swap their value. You should make a to be equal to b and b to be equal to a. Okay, so we've added our prototype there, like I taught you guys. I'm teaching you the right way to write code, the right way to program, the right way to address programming issues. You know, I try as much as possible to want to follow good conventions while writing this code. So stay up and doing and you get it right. Yeah, so the name of this thing was, I think, swap, right? What did they call it? What's the name? Where did they compile this stuff? Okay, one dash swap dot c. That's the name. It's one dash swap dot c. So let's go do that. vi1 dash swap dot c. vi1 dash swap dot c. Yeah. So what do we do? First of all, like I said, we need to solve problems in our minds before we go to the computer. We want to understand how to swap the value of one integer into the other integer. Now, see, you can't do this by just saying a is equal to b, b is equal to a. You can't do that by saying that. We have to clearly think about it. What do we do? If we want to make, already have a variable a and we have a variable b. Okay, let's see. Let's do a simple math. Let's assume that the value of a was 5. Let's assume that a was equal to 5. And let's assume that b was equal to 7. So what this assignment is saying that we should make b now equal to 5 and a equal to 7. So what we can do here is, if I have a rough understanding of this stuff, we can say that we can say that a is equal to a plus b, which will be equal to 12. And then, yeah, a will now be equal to 12. If we see, I'm going to tell you why we need pointers. You know, if a now is equal to a plus b, and that will now be equal to 12, then the value of b will now be equal to a, which is 12, minus b, that is 7. Remember, a now should be equal to 12 because a is equal to a plus b, which is now 12. B should now be a minus b, which is equal to uh which is equal to 5 now, because b was equal to 7 before. So b now should be 5. So we can do the same thing to a. A should now be equal to a, which is 12, minus, now see where the technicality comes. Okay, minus b. Yeah, a now will now become a, which is still 12, minus b, which is now 5. So 12 minus 5 will now be equal to 7. Yeah. So that's that. This is what I'm thinking in my head. I've solved, remember, I have to solve the problem in my mind first. Let me see you guys. Yeah. I have to solve the problem in my mind first. I can't just go to my computer and start solving the problem when the problem is still a problem in my mind. So the fact that this is achievable in my mind, I can now put it in programming. I can now write it as a code. Now, this is just a rough sketch. If we were not to be using pointers, this is not possible in C right now. Because why this is not possible is because at this point, we are saying A is equal to A plus B, which is now 12. And B is equal to A, which will now be 12, no longer 5. Okay, Let's write it as code first. Let's build this out as a code. I feel like if I build this out, I write it in C, it's going to be easier for me to, communicate to you guys since you're seeing it, you know, already. So first things first is we are going to include our main file. Include uh include don't want to make the same mistake again. Always leave a comment, guys. Always leave a comment. This stuff was swap, right? Swap int. So let's void it. We don't want to see any return. We don't want to see any return values. So we have to void this stuff. So we'll swap int uh swap underscore int. Nope. So at the top, we are going to actually pass the addresses of A and B. So int the address of A, comma int, you know, B. So these are okay. So what next do we do? Remember what we did? The first thing we wanted to do was to, sum up. We wanted to increase the value of A, right? So how do we do that? We are going to say a pointer A is equal to, no, let's say plus equals. Let's be mature. Yeah. So you can say it's equal to A plus B, but then I don't want to do that. I want to show you a more mature way to write this stuff. So this is it. This is a more mature way to write this stuff. A is equal to plus equals B. You know, remember, these are pointers we are using. So we are working with. So the pointer to the address of A is equal to the address of B. And then we can go further. Don't want to give too much spaces. We can go further to say that uh should we work for B first? Yeah, I think we worked for B first. B is equal to the address of A, the value there, which is now in my mind 12. I'm still seeing the values I'm using to calculate this thing in my head, you know, plus the address of B. And we want to change A as well to equal to A itself, you know, minus B itself. Yeah. So this is what it feels like. Okay. Um, I see an error here. How I know that there's an error is the color the color is not the right color. Yeah. So that's that was a typographic error. Okay. So ls, I think we've got just all that it requires us to get. Okay, so here they are saying that we should compile this. So I think I was lazy while compiling this. I used only GCC. Let's copy this stuff. So we are compiling. Remember, this is like creating a bundle for both the main.c file and the one-swap. Okay, we have not copied our main.c file that was provided here for the test. Remember, these main.c files, you should be building them. You should learn how to build main.c files to call stuffs. It's very simple anyways. I know that I've taught you, so let me copy this first. I guess this is the top, right? No, it's not. Yeah, so that's the top of it. Let's go paste this and see what's inside. uh, cat1 dash main dot c, and let's paste this stuff in here. And then what does this do? Let me show you what this does. It initialize a, and it says a is equal to 98 here, and then it prints it still declares b and gives it a value of 42. So at the first instance, a is 98, b is 42, and what it's saying, it will print it out as it is here, and then it's going to call our function that swaps, and then it's printing out again the value of a and b. So we want to know if a will now be 42 and b will now be 98. Okay, so that's what this does. It's not difficult. It's a very simple code. It's just creating an integer. Now if you're seeing here, I'm going to show you the difference between this and my function here, what my function creates and what this is. Let's do this. One dash swap, right? Yeah. So you see this function actually creates a pointer to the address of a. It's not actually using a itself. It's pointing to the address of a to change the value of what's in the address of a, you know. And same for b, and we are all using addresses. We are working with the addresses for every single thing here. Okay. We are pointing to all the addresses. So let's go and run this stuff. Let's run this stuff to see. I want to copy this stuff. I feel lazy today. I feel like today. Please, any questions? Do we have questions so far? If you have, leave it. I want to see your thoughts. Okay, so there's no error here, and it's saved in one dash swap. In essence, we can run one dash swap. Okay, so you can see at first a was 98, b was 42, and after running our function, a became 42, b became 98, just as we calculated, you know, just as we calculated in our minds. That's what programming is. You have to solve the problem in your mind first. You can't just start solving a problem that you've not solved in your mind, on a computer. No, you are the programmer. These problems have to be completely solved in your mind first before you start pressing the computers. you know your mind is the first thing. The first place to solve any problem is your mind first, and then any other computer. So you have to work out an algorithm that solves the problem. Some other person might think about this particular problem that we just solved like this. Some other person might think about it in an entirely different way, you know and still solve it and get the same result. Programming must not be static. We are different people. We are going to solve and think different ways. So that's what it is. That's what it is. I think we still have a few minutes, so I'm going to take one more, just so you understand what pointers are. Pointers point to the address of a variable. They don't change the variable directly. They change what's on the address of that variable. Okay, and then um let me see. You guys should put a question, through to me. If you have something you don't understand yet, put a question through to me. If you've read your materials, you would clearly understand what I'm talking about, because the materials, especially the document ones, they are built to give you full understanding of you know uh the this particular class of this concept of pointers. So you just need to practice a little bit. You have a hang of it, just like I have too. It's not going to be really serious. I'm going to take one more, I guess. Yeah, just to because we are running out of time. These classes should run for 1 hour. And if you have questions, if there are assignments that you're still unable to solve, I would really appreciate you guys to leave them on your platform. That one that you're struggling with, you're not able to solve from last class, from previous classes, especially the assignments towards the end. If they stress you too much, leave them. Ask questions. I'm still here. I'm still available. I'm going to solve it and as well give you. Anyways, you guys have learning is much more easier now because AI is so crazy. I know that it can break down this stuff and teach you, and all you need from me is to show you the right path to learn and explain a little bit so you understand when you learn on your own. But I'm here and we are doing this. We are in this together. Okay. Um so what do we do? What do we do? Okay, let's read this next question here. This one says print a function that returns the length of a string. So, like I said, first things first, solve the problem in your mind. There are many ways we could return the length of a string here. So, how do I want to do this? How do I want to return? Oh, okay, we talked about arrays. Let me use an array to count how many letters are in the string, characters rather are in the string, and then uh, we'll go from there. Let me do an array again. So I'm copying this prototype because I want to go through it straight in my main.h file, vi main.h. You see how easy I make this thing look? That's how easy it should be for you to, you know. But I'd like you guys to type, you know, so you build a little bit of speed. Don't stop copying, like don't copy like me. I can type fast. Just copying to relieve stress. I'd like you to keep typing so you get conversant with typing. Remember, if you work in a team of engineers, if you don't know how to type, you know, you'll be, in fact, you can't work software engineering and you are struggling with basic things like writing, you know. You should know how to write as a software engineer. Okay, so we've done that. We have our main H file correct. And let's see what did the question prepare a main.c for us? Yes, it does. There's a main.c file, and what the main.c does is it takes in a character, my first string length, and then int len, which is int length, is to call our function. This would be our function that we are building, and that should print the length of the string. So that's just that for that. Let's copy this main.c file and create it. So this is supposed to be 2-main.c, and then our other file should be 2-stringlength.c. So let's do that. Let's cut this into 2-main.c and let's paste this stuff. Control done. And then we are to create 2-stringlength.c. Okay, so that's what it is. Like I said, the very first thing that we should do here is never to forget to include our main the h file where we define the prototype. Remember, the functions should be declared as well. Same way we declare variables. We like declaring variables anywhere we like inside any block of code that we like. But for functions, it makes more sense to declare them in like a header file or something. So that's what we are doing. We are defining them there. Remember to leave a comment again, and then we should start by building the function. So it returns an integer and underscore string len. Yeah, that's what it is, and it takes in a character. So you can see that our code can actually take in a character and return an integer. I think this is the first time we are doing that, because we want to return a number. showing the length of the string. So let's do character, let's point to the address of s. So we've moved on, yeah, and let's return. We are actually returning something, right? What do we want to return? What do we want to return? Okay, I will return inside the while loop. Let's create a while loop. Hmm? Let's create a while loop. What do we want to do? Okay, let me explain what I'm thinking in my head right now. Remember, we want to count. We want to count. We want to. What we want to do is we want to count a string, the values in a string. That's what we want to do. How many are there? How many characters are in a string? So all that I think that we have to do is, you know, we we let's form the string into an array. Let's look at the string as an array of s. So for each value of s, we should increment I, which is the counter in the loop. So by the time it finishes counting through, we look through the string. We've known the total number of i's. I will keep increasing now. So all we have to do at the end of the day is just to print I, right? And that's what it is. So let's do that. Let's form a form of an array here. Let's do that. Let's do a while loop, you know. Yeah. I want to say while. I want to say while. Okay, let's initialize I first. Int I. Hmm? Let's give it value of 0. Int I is equal to 0. So while we look through this character s, remember in our question that it is x. Remember here, see here, the string we are given here, you know, the function is to collect a string. The string, which is this one here, that holds all of this. This character here, character string, holds this string. A string is a group of characters, like we said before. And then int len is to check the length of this entire string, which is to say that if we can look through, if we can look at this string as an array and we can count the number of characters in this array, that's basically what the question is asking us for, you know. So if we come here in our work and we just look through s, since the prototype requires us to use s here, if we just look through s, so we say while, we have to open a bracket here and say while s at position I, we'll have to close this. I have to close this. Yes, while s at position I, what we want to do is we want to increment. Okay, we don't even have to. Okay, we want to increment uh I. We want to increment the value of I. So we want to just say I plus plus, right? We want to just say I plus plus while s is at position I plus plus. So the next thing we want to do is, I guess we want to just return the value of I at the end of the loop. Remember, this loop is going to run till there's no longer a value of I, you know. There's no longer a value of I. So let's return this stuff. So return I at the end of the day. So the value of I should be S. Each time for each character in the string S, it's going to, if there is a character, if this condition returns true, there's a character, it's going to say I plus 1. Remember, I was 0, so for the first time it's going to be 1, you know. That's why we do not say I is equal to 1, because the first time it increments, it's now going to be 2. So we want it to start from 1. So I is equal to 0 here. For the first character, I will be 1. For the second character, I will be 2 till the end. I guess this is all there is to this question, actually. Let's see. Let's go back there and copy what we need to run it. This is it, what we need to run it. So it's printing into 2 dash string length. Yeah, so we have to paste this here. Hopefully there's no error. Yes, there is none. And ls, what are we running? 2 dash string length. So 2 dash string length, and it says 16. So let's go count our main dot. What's in our main.c file? No, let's cut it. Cut 2 dash main.c. So let's count it. Is it up to 16 characters? It looks smaller to me. One, two. Remember, a space is a character too. A space is a character that is stored as well in the memory. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So yeah, so that's it. So 16 of them, we've done that. That's an array. So you've learned a few things in this. We are up. Our time is up. You know, our time is up. What do we do? What do we do? Let me see you guys. What you guys have to say. Let's see what you guys have to say. So let's have a brief conversation. Anybody has something to say? Um, so that's what it is. That's what pointers feel like. It's just Error Jack, hello to you too. It's just we pointing to the address where a variable is being stored, and then we are able to manipulate the variable anyhow that we like. So this class is exactly an R. This is how we think. This is what I wanted to show you. I wanted to do your assignment, like study for you guys, so you know how to think and how to tackle the rest. So what I want you people to do now is go back to the questions, solve them as much as possible, solve as much as you can, and then when you run into issues, remember to hit us up at our platforms